everybody, in this lesson we're going to talk about scientific notation. The big idea here is that scientific notation is a method of representing large and small numbers in a more simplified and concise way. So first of all, what is scientific notation? Now, we know it's a way to represent large numbers, but also small numbers. It uses 10 to the power of x as a multiplier for a value. Now, what does that mean? Some examples. Let's say, for example, you have 4 times 10 to the 5. What does this mean? It means, actually, if you don't know, it means 400,000. Another example, so this is a very example of a very large number getting represented by scientific notation. What about this one? 4 times 10 to the negative 6, for example. What this means is you're going to have 0.000004. So this is a way to show a very small number. So we have a way to show a large number. We have a way to show a small number. So how do we use scientific notation in our calculator, for example? How do we represent it? So on your calculator, you have buttons. Now, what you want to do is you really want to look at the buttons such as EXP, EE, or there might even be a 10 to the x button. But you also have the exponent button, for example, so you can punch it in manually. The exponent button can usually be seen as y to the x to the y, or a hat button, like an arrow pointing up. And what you want to do is whenever you punch, for example, if you want to punch, let's say for example 3.1 times 10 to the 4, you should expect to get 31000, 31,000. So here's my calculator. What you're going to see is, let's try punching in 3.1 times 10 to the 4. So I could punch it in using the exponent button, so 3.1 times 10 to the power of 4. As you see, I punch in 3.1 times 10 to the hat. That's my exponent button. 4, which is this x to the y button. And I'm going to get 31,000. What happens if I use the scientific notation button, the EXPE or 10 to the power of x? In this case, that's this button, EXP. Your calculator again might have EE or 10 to the x. So watch what happens when I do that one. I'm going to 3.1 times 10 to the, 3.1 EXP. When I do that, it's going to show an E plus some number. So what that means E is that 10 to the power. It's asking you, what power of 10 do you have? I'm going to put the number 4. And watch what happens when I hit equal. It's going to give me 31,000 again. So practice doing this on your calculator. You can pause the video at any time. Practice this, and you will see. So our first question is, how do we multiply? That should be multiply scientific notation. Oopsie. So how do we multiply scientific notation? In this case, what you want to do is, you got to make sure you plug into calculator with brackets usually. Now this isn't actually as big of a deal right now because you're multiplying, but it will be a big deal when you talk about dividing. I'll talk about that when we talk about BEDMAS. So let's try plugging this first example into our calculator. So you have 2.3 times 10 to the 2. So 2.3 times 10 to the power of 2. So I'm going to do it that way first. Times, I'm going to use brackets just to show you. So before you do anything, you want to put bracket before your first value and after the 10 to the power. Times bracket 3.44 times 10 to the power of 3, close the bracket, equals. And what you're going to get here is you're going to get 791,000 and 200. It's equal to 791,200 something. So try it on your calculator, see if you get the same value. But what if we talk about division? If we want to divide scientific notation, this is where put brackets, or else calculator does BEDMAS. Okay, if you don't put a bracket, your calculator will do BEDMAS for you. I'll show you the first way what happens when you do it with brackets. So what you have here again is 2.3 times 10 to the power of 2. Now, for the first one, I usually don't put brackets because it's not needed. For the second one, I need to put brackets. So in this case, I want to make sure I have a bracket around the second one, the thing I'm dividing. So I divide it by bracket 3.44 times 10 to the power of 3, close bracket. Then I should expect to get, in this case, 0.06686. So equals 0.06686. Okay? Which makes sense because this is a smaller number than this one, so I should expect a number that is smaller than 1. Look what happens when I don't put a bracket. So I'm going to put 2.3 times 10 to the power of 2, okay? Then I hit divide by 3.44 times by 10 to the power of 3. And I'm going to get this number, 66,860. So what I can get here is 66,860 something. Does that make sense? You're dividing a number that is smaller by a number that's larger. Do you expect it to be that large? And the answer is no. So what's happening is, when your calculator, what it did was, instead it did this. So here, 2.3 times 10 to the power of 2. Okay. When you got to here and you hit divide, the calculator, yes, it divided 3.44 for you. But once it does that, it's going to do 230 divided by 3.44. Whatever this answer is, it's then going to multiply by 10 to the power of 3. And that is why you get 66,860. So you just got to make sure that you put brackets. So how do you add or subtract scientific notation? Same thing here. You got to make sure you put brackets. It cannot be stressed enough. Put brackets, or calculator does BEDMAS for you. So let's try to look at these two examples. So your first one, again, the first one doesn't really need brackets, but the second one usually does, and always does. Put brackets around the second one, or else your calculator will do BEDMAS for you. So what you have here is, the first one is 5.6 times 10 to the power of 3 plus bracket 4.43 times 10 to the power of 2, close the bracket, is equal to 6,043. The second one, put brackets, 4.545 times 10 to the power of 3. Okay, that's the value. Minus bracket 1.3434 times 10 to the power of 2. Close the bracket. Equals 4,410.66. 4,410.66. So that is what we have here. We gotta make sure, again, you put brackets, or calculator does BEDMAS for you. So what does really scientific notation mean? Remember, it's a way to represent large numbers and small numbers. But what does this 5 or negative 6 in this case, what does it all mean? What it means is this. It has to deal with how the decimal rule moves. So for example, when you have a value, if you move decimal to the left, what's going to happen is the scientific notation, the 10 to the power x exponent, exponent gets larger. Okay, and I'll show you this. So for example, if you have, let's say, 2.34 times 10 to the power 4, if you move this exponent right here, this decimal right here to the left, what it's going to end up with is you're going to get 0.234, And this thing gets larger times 10 to the power of 5. That's what's going to happen. Okay, what happens if you do the opposite? You move decimal to the right. Then, in this case, the 10 to the power of x exponent gets smaller. So, for example, if you look at this one, 2.34 times 10 to the 4, when you move this exponent to the right, like this, you're going to, or this decimal to the right, you're going to get 23.4 times 10 to the power of 3. That 4 gets smaller. Why is this important? This is important because you can actually always verify if your scientific notation is the correct number or not. Because what's going on is when you want to convert your scientific notation into standard notation, just regular number, what you're going to do is you want 10 to the power of x, whatever that value is, to become 10 to the power of 0. Because 10 to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So, the shortcut way, though, is this. The 10 to the power of x, whatever the x is the number of zeros added before the value. Or, not before the added. Okay? It depends how it's added. If x is positive, you add after value. If x is a negative value, you add before your value. So let's show an example. Okay. Let's look at, for example, 8 times 10 to the power of 4. This 4 here means that it's positive, so you add zeros after the 8. How many zeros? Well, you're going to add, so 8, 1, 2, 3, 4. There's 4 zeros. Okay, but what happens if it's, for example, if you have, let's say, 8 times 10 to the negative 4? Well, in this case, the negative 4 means that you have 4 zeros before the 8. So you're going to have 0, so decimal. So it's always decimal, 0 decimal, that's 1 0, 2 zeros, 3 zeros, 4 zeros, then the 8. There's 4 zeros right there. But what happens if you have values after the 8, for example? Let's say, for example, you have 8.12 times 10 to the 4. How does this work? Well, those 1, 2 right there, that's going to count as zeros. Okay? So what you're going to get is you're going to get 8, 1, 2. That 1, 2 is already counted as zeros in a sense. So how many more zeros do you have to add? If there was 4, you add 2 more zeros. So that's only if it's positive. What happens if it's negative? If it's negative, for example, if you have 8.12 times 10 to the negative 4, what will happen? Well, because this negative 4, these zeros are added before the 8 even shows up, it actually has no effect. So what you're going to end up with is still 0.000812. Those zeros are still there. So make sure you practice this. So whenever you have a positive x value, a positive exponent, that's how many zeros you're going to add after the value. If it's negative, it's how many you're going to add before. If you already have values after the decimal, those values after decimal count as zeros. So that's why this is 81200. What if you want to go backwards? What if you want to go backwards, convert a regular number into scientific notation, you just perform it backwards. So what you want to do is keep first value or first digit and put a decimal after plus any additional values. Okay. Now, what do you do now? Well, if value is greater than 1, 10 to the power x exponent is positive. Based on number of digits after your first digit. So for example here, if it's 912, what you're going to see is you're going to have to first put a 9, then a decimal 12. Now, how many values did you have after the 9? Well, after decimal. You have 2. Because you have 2 here, that times by 10 to the power ends up being, in this case, times by 10 to the power 2. That 2 represents that there's 2 digits after the 9. Okay. If value is less than 1, the 10 to the power of x is based on number of zeros. Before first digit. Sorry that I'm running out of room, but I'll show an example. Example here, if it's 0.00912, this one is still going to be 9.12, but how many zeros do you have before the first digit? You have 3. So it's 9.12 times 10 to the power of negative 3. As always, make sure you keep yourself safe and healthy, and I'll see you soon.